Hello, welcome to my channel. So in this video is problem number 2 for the curvilinear motion. So previously we learned about how to calculate, compute the velocity and acceleration vector and magnitude. Okay, so in this problem we move on to the curvilinear motion with the constraint. So the constraint is simply refer to the movement that was dependent on another movement, like shown in your left-hand side figures. So in this problem, they said that the hydraulic actuator move pin A along the direction shown with a constant speed of v equal to 1.2 meter per second, which is on this direction. Now the slot guide rotates about point O, and the motion of the pin is constrained to the slide along this rotating guide. So which means this pin from the actuator will move and push this green slide to the left side. And since it has a rotation point at point O, that means this green slot will make a rotation about this motion. Okay, so then the problem then was provide that the instantaneous position vector from the pivot point of the pin when the angle is equal to 45 degrees. So at theta equal to 45 degrees, they are asked to determine the velocity in r direction, velocity and acceleration in r direction and theta direction. Okay, so we will step by step learning how to solve this problem. Okay, so as always, I will put the reference r and theta perpendicular to each other at point A to indicate that this distance indicate the positive r, this distance indicate positive theta. Then we then do the distribute of the velocity. So the velocity here is considered v, right? But if we distribute it into two axes like shown here, we know that the v sine theta will point toward positive theta, v cos theta will point to the minus or negative r here. So to determine the function of r, meaning that to determine what radius will be according to the push of the actuator here, we will then have to look on the relationship between this theta and the direction, the displacement r here. So you see that I draw this triangle based on this triangle here. Okay, so that means this is 0.15 meter, which is constant since it is the altitude dimension from O to hydraulic, which they both not move in y-axis. Then now the inclined length is r, which we wanted to know the relation. Then we do the geometry. Now we know that r will equal to 0.15 divided by sine theta, and if we substitute 45 degrees, we will get 0.212 meter. Then we will then try to determine the angle theta, the theta dot and theta double dot by firstly recall the equation of the vector in the velocity vector. Then we know that v theta, or the velocity in theta axis, equal to r theta dot, or in this case the velocity at point at the same direction is v sine theta. So that means v sine theta is equivalent to r theta dot here. So we try to convert the velocity from one direction into theta and r Okay, so we arrange the equation shown here, and we get that the theta dot uh, is dependent on velocity v and theta. Okay, so which means if we substitute theta equal to 45 here, and we substitute v equal to the constant of 1.2, then we will achieve the set theta dot equal to 4 radians per second. Okay. Now, if we perform the differentiate of theta dot into theta double dot, we will then get that um, theta double dot equal to 2v sine theta cos theta times theta dot divided by 0.15. Now, the theta dot, where it came from, okay? So it come from the when you differentiate this term right here. So we know v is constant, right? So it's not a variable. So this is not constant, the variable. So we differentiate this one. So sine square theta, we first bring 2 in front, and then we differentiate the sine into cos here, and then we have to differentiate what inside cos theta, which is here is theta, right? So differentiate of that is equal to d theta by dt, or in short we call this one theta dot. That's the reason why this theta dot here is showing in here. Okay, makes sense. Now, okay, excuse me, yeah. Now that we get that out of the way, we then proceed uh, with the substitution of the parameter we know, velocity v, angle theta. Then we then get the result of the theta double dot equal to 32 radians per second square. Now let's look into the radius, velocity in radius. First, we bring out again the vector velocity. Then we know that velocity in r direction equal to r dot. Velocity in r direction, when we distribute it, equal to v cos theta. Okay, but it's in negative direction, so we put minus sign in front. Then the r dot equal to minus v cos theta. We then substitute v and theta 45 degree. Then we get r dot equal to 0.848 meter per second. Then we differentiate the r dot here and differentiate cos into minus sine, and differentiate theta into theta dot here. Then, well, we get this r double dot equal to this relation expression. Then after that, we get the final result when we substitute v, theta, and the theta dot here. Got 3.39 meter per second square. So that's it, the end of this problem. Thank you for watching. I hope you understand how this problem has solved step by step. And thank you so much for watching. If it possible, I'd like you to help this channel by pressing subscribe button so that we will see each other again in the next engineering problem. Okay, we'll solve and learn together. Thank you.